we're not a very big company. We're about 20 people. The only nice thing about it is I think we're building a very good product which we think fits into the market. Anyone from technology would think this is nothing new, it's just a content management system. But when you tailor one of those to a specific industry, it adds value really. So we are targeting the legal industry, specifically at lawyers and associates who work, and this new generation of lawyers who've actually been more literate on using computers. Because if you look back 20 years, they've been using a lot of desktop publishing tools, and that's the only way they know how to work with it. And in all this time, what's happened is they've been preparing documents which get printed or circulated among other people in Word, but there's been several people collaborating on it. And I think that naturally calls for a use case for using a content management system. From an information system point of view, it's just a bunch of users working against a bunch of documents. That's what collaboration platform is about. We're building this predominantly on .NET, but the store we have under the covers is Neo4j, and the other one's RavenFS, which is a file store. RavenFS, because it just comes with encryption out of the box. We could change it in the future. I'm not that bothered by it. But an interesting choice of technologies because 8 years ago, when I was working in a startup which was also about a content management system, we built it on SQL Server. We stored web pages in a content management system sitemap as blobs in the SQL Server, alongside information such as who the user is, what he's authorized to do, what other metadata is related to him, basically. Great, but as the content increased, the user can't even log on quickly. That's just the way IOs work. You have a store, you have data that's being used upon the same disk. You're now thinking about sharding, splitting the data, logically, physically, whatever. It just comes to a grinding halt. And then if you have the money, yeah, I'm sure you can find the hardware and the kit to sort your problems out. We're not there. We're a startup, so that's not where I want to be in, I don't know, 2 years' time, 3 years' time, if we actually make any money. There was a new set of CMS systems attempts built, especially, I don't know how many of you have heard about Umbraco. Umbraco is a CMS platform which actually went through its ups and downs. And back a couple of years ago, there was a big conference where they kind of gave up on that release, actually. And a lot of people came back pissed off saying, I'm going to build this in NoSQL. If you actually look at Rebel CMS, as the name suggests, on GitHub, it's actually was an attempt to start a CMS on a document database. But the minute you get into this context of putting content and relational data together in any store, it doesn't matter what store that is, even a graph really, I think you're actually just going to reduce the life cycle of your product anyway. It's just going to get there quickly. Either your cost is going to go up, your staffing is going to have to increase just to manage this whole beast, really. It all depends. Everything depends where you are. You're on the cloud, you're on a hybrid data center, that depends. But the case remains that if you do not split your data properly, and based on how it is consumed and who's consuming it, if you don't store it in the right places, you are, right at the outset, even before you've got any analytics to the data, going to disadvantage your business, really. And I think that's just the beginning use case. Everyone knows what polyglot persistence is. Wikipedia funnily says it's a fashionable word. I think this concept's been around for a long time. We just haven't given it a name. And in our case, what we do is we took users, the organizations they're related to. If I forgot to tell you, we're a SaaS platform. So we have tenancies. We have every company is a tenancy on our platform, and users who are actually in each tenancy are related to that tenancy. And on the other side, on the collaboration side, we call our content documents. It's just a logical block that splits into several parts of content. Each piece of content is unique in the sense that it's valid on its own, and it is its data integrity is right, really. But on the other hand, all this relational information, such as users and organizations, it just exists for the sake of supporting that content, really. So we put a graph in front of all the content, really. That's what we've done. And all we do with the file store, which is Raven FSI, as I pointed out before, is it just streams files back and forth to the web layer, basically. The graph itself is a complete representation of what's going on in the system, and that cannot be possible with some modeling issues I'm going to talk about in a bit. But broadly speaking, I have to tell you, I had a discussion with my CTO, and I was told not to talk about certain capabilities of a product. So I've thinned down the architecture diagram just for this conversation. We have these collaboration services. As with anything else, we have a couple of stores, a Neo4j store and a Raven FS store. Neo4j, you guys are familiar. Raven FS is a byproduct of RavenDB. It's supposed to be very good at asynchronous streaming of files. I'm sure you find other products like these, Ryak, which is a more established product. We just took the bet on that, really. That's all. The publishing service is something that preps the document every time a user is ready. We have some monitoring stuff and a couple of services, and the content editor, which is any browser-based editor, really. Anyone familiar with CMS? This is nothing new. As I said, we are a SaaS platform. We're competing on the web. The first point of reference is, Word does it, you don't do it. There's a reason. You just don't need it. But that's a common conversation. I think that last one says it all. There's this perception that everyone wants to change the same piece of content at the same time. It's never been true, really. It's just been something I think I need, but when I actually get to it, you and me are not going to be working together on the same piece of content. You're just going to wait for me to do something because you just don't want to be unproductive by doing the same thing I'm doing. That's just the way we work, really. The rest of the stuff, every CTO will ask you for this, so that just came on the list, makes it the list. That is the domain I was talking to you about in the beginning. So we have a user related to some organizations. That's a session. We just track every time someone logs on. We just have a node created so that we can go back historically and look at how many times the user has actually got onto the system, how long were they there for. The document is the primary block of content from a user's point of view. It's grouped into the concept of folders. Lawyers use other terms. I'm not using those terms here, but that's just the logical thing. Now, I could have started at this model and actually had one big graph sitting across the entire Neo4j store I had. And actually, as my volumes of data increased, I would be tweaking and tweaking and tweaking my system's performance forever. That's just the way it works, really. But there comes a point where you should actually think, we did have bounded context in services for a reason, and that probably applies how you isolate your data as well. And what we did was we actually split the model into two parts. So that's all you have as a tree. The document user is not the real user node you see. The user in that context is just authentication information, security information. This is just a reference to that aggregate from another service. So the graph itself has been split by using bounded context. So actually, if I wanted, I could actually isolate every graph at the level of a document, really. So someone who told me we need tenancies and data isolation by documents or tenancies, I get that out of the box by playing with my graph model, really. The document has information about where it's stored in the file store. That's just a property. Every part of the document that is here, these are fragments. I won't tell you what markup language they're stored in. It's just XML. But it has a URI to the file store. The document on the top knows where to go, basically. That's just the way we've modeled it. So what happens is every time some request comes to the collaboration service, figures out where it needs to store that file, goes and comes back, and it's really quick. This because it's Neo. So we are actually making the user work with the graph all the time, and we get our speed from there, actually. And the only time they see latency is when they're pushing a big part of content back to the server in our file stream. And that is down to how quick your network is and also how bad my code is. So because we tend to wait on asynchronous requests brilliantly, and that's just the best part of development. And we'll be sitting there for a few minutes wondering why the connection timed out. So that part content, there's scope to split these into as many subparts as you want going into the future. So what we have is kind of a very flexible model. This is the other side of the domain, which is just the administration phase, where tenancies and users are maintained, so nothing new there. Now comes the interesting part. How did we build versioning into it? I think this picture should tell you a bit. So when a new document is created, if you're wondering what WIP is, which I'm sure you don't, it's work in progress. That's where all the content changes are happening. Anyone who's working on a part in a document is actually changing content here, actually. And when the part itself is ready to go for everyone else to see, we call it a check-in, a checkout, just like SharePoint does. Thank you, Microsoft, for those terms, because lawyers are very familiar with those terms, and we're just going to stick to those, really. So what we do is, when you check out a part, we clone that node, create a new copy of the content for you at that point in time, and let the user work here. Now, the brilliant part of this is, if he decides to check in, we just switch the relation and update the URI of the part in the work in progress. Now, if he decides to abandon it, I don't do anything. I just say this checkout was abandoned. And another thing, versioning, right? That document edits node on the left seems like the completely pointless node in this diagram. But it is the source of how I would actually go back and look at what a user has done to a document in historically, really. So it's another way of looking at the graph. I'm sure time tree is a great example of Neo4j traversing it in two different ways. It's no different. We're not doing anything different there. In fact, we haven't plugged in a time tree, and that's one of the things we want to do, really. So really, that's your sitemap. In a CMS, a document tree in a DMS, that's what we're working against. I think the versioning part has several, I'm not going to go there, sorry. Yeah. One thing I want to touch upon is that model, does it look like a database table with very system-specific names and tasks, relations associated with it? It's quite common, if I put it in front of one of the guys in my management team, to look at it and understand what's going on. And that is only possible if you don't break down your graph so much that it almost becomes a representation of the system and not the user domain you're working in. It would have been very easy for me to actually call that part, I don't know, fragment. That's one simple thing I could have done to the domain to actually screw it up for the user, really, to understand. The other thing is, if I did that, I'll have to translate that information back for the user if he wanted some analytics information from it. So at the outset, trying not to model the graph too much to the lower level in terms of what the system solution is, but what the user's domain is very important, I think. If you don't do that, you start losing the value of visualizing that data right from the outset. That's just what I found. I'm sure in other domains, it could be different. Scientific domains, mathematical domains, it might be different. But in a space like this, where collaboration, you're dealing with users who are only able to work with computers, they don't know programming, really. So that's that. The graph itself, because we split it into several parts, we naturally have segregation of data, and it's easier to scale for us from that point of view. But we've made sure we don't have cyclic graphs, just as a choice. I don't know why I did that, but we just started doing that, and I haven't run into any issues of migration or dealing with unique cases in separate places. All the data is not connected. I think you wouldn't actually put everything in a table in a SQL database, or join up all the tables in one database when you have multiple tenancies and not have multiple databases. So we've been working on, sorry, there's a bit of technical stuff here. I know this is a business track, but I thought I should quickly point out a few things we ran into, because of which I used the term lap times. There's two things for our business. One was we started 4 years ago. 3 years ago, we didn't have a product. We spent about X million. Let's not shame it. But when we got to that point, we actually started revisiting the architecture and started rebuilding the stuff into a more aggressively user-friendly product. But we just wanted to get there in 8 months' time, and that was just the way we were looking at it. And I cannot tell you how thankful I am that I actually chose to use Neo4j, in the sense that some of those versioning problems I just solved there, I don't really have much application tier code there. That just came about the model. Yes, it worked out for me in this context. Great news. But that whole layer on top of all the content is in its own way providing that protection layer for that content, really. So when people make mistakes with the content, we're able to switch them back and forth. I'll tell you about a support incident yesterday night from a lawyer I had. I think that's a great example for why I wanted to keep the graph as was. So in many ways, it seemed to make sense that we've been iterating for the last 8 months. We work in a very agile manner, and so I say. So we've been working on a feature backlog, constantly building and dropping the product into our beta environment. And actually, in all this time, we've constantly improved the platform speed and performance as well. And that's where I think there's a lot of a relation to the word lap times. And yes, I love Formula One, so it had to come about, really. I think something most people forget, as soon as you put a whole team of people in front of Neo4j or any new graph technology, it's exciting. But we forget the principles of the old databases. None of that had anything to do with it being SQL Server, Oracle, or anything. It was just database principles. Things like don't read the information if it's not going to change. Or when you're writing it, just think about concurrency. Those principles haven't changed even in Neo. Talk to the Neo guys, they'll tell you. We get caught out by this in any new implementation on any new technology. It's as if we've started all over again trying to build a data layer. It's as if we've never done it, really. Anyone who's worked in this space for 5 to 15 years, it's the same problem, I think. The concept of reuse, I put that point there because I think we got caught out by reusing Cypher queries with full graph scans. I can't show you the code now, but I'll tell you this much, that if you're trying to reuse Cypher, be careful about what it's actually resulting in. If they are any different from each other, just don't bother reusing it. Try to duplicate your Cypher and isolating it for the query purposes. So query A asks for one projection of data, query B asks for another projection of data. Just keep it separate. Don't try to be too clever reusing code. This is not the point. When you've really got a performance system, yeah, think about it. I wouldn't do it day one, if I'm honest. Some of the Cypher tuning stuff here is an exercise I was recently doing. And I was quite thrilled, actually, how Nia actually lets me quickly do it. I had to switch on query logging on the server. And I had to switch on output all the metrics of the server. And that just told me how bad my application was. I quickly could see where my problem was, while some of the people were saying, we should get some Neo consultants in. Yes. Did we look at our stuff? No, we haven't. So for the last few months, we've been tweaking the system a lot. And trust me, we're miles ahead of where we are. And I'm very happy about where that has gone, specifically in terms of the progress we've made. Some of our guys are here. I don't know if they're here, but they've all done a great job, actually. These Cypher tuning things, I'm sure Mark Needham's going to cover in his technical track anyway, so I'm just going to move on to not the tuning the server. This is just some pointers. I'm not going to go into the detail because I'm sure everyone who's worked on Neo4j is familiar with these. I know I put that point about disk speeds. Who cares about these days? But I did because I inherited stuff which is so old. This is probably the interesting bit for a lot of people who came here for the business track. So as I said, we had a team of around about 25 people when I joined, building the system. We were nowhere near the word collaboration or anything really. We were still baking out this massive algorithm on differential synchronization. If anyone's heard it, it's about synchronizing changes between content changes. There's a paper by Neil Fraser from Google who's written it. So I don't know why we were doing this, by the way, because anyone who's built another CMS would think that's not the crux of the problem. The crux is get a system working in front of the users, let them actually create some content. Don't worry about managing changes later. Not being, very, rude, but that problem's been solved by so many people so many times that you shouldn't be solving it. That's the kind of problem that is. So we kind of had a build versus buy debate. Bought a few components, by the way. All this gain has not been because we just used Neo4j. I know Anthony won't like me saying this, but it's predominantly because of Neo4j, but there's a significant set of other tools. So I'd give it 1/3 the credit, I would say, because I always have this in the back of my mind. In a 3-tier application, if you're building a data tier, which is so thick with ORMs, whatnot, the whole jazz, as every other application has, you're probably building up a layer with a bunch of people and costing a lot of money, really. If you don't have to do that, that's the simplest thing you can't do, basically. Because if you're reading and writing data, and you can do it pretty easily, yeah, I chose the graph. And that worked out for us. The team that actually did it was half the size of the original team. And I think that speaks for itself in terms of how it enabled us in the transition. One of the things I haven't mentioned here is we were based on SQL Server, Neo4j, and RavenDB, a mix of relational and document databases where content was fragmented and thrown across all the 3 different stores. As you can see, speed was not on the bucket list. We just took like a few minutes just to log on, really, because you had a message queue on top of all these to actually service a log on. So anyway, rant over. The system's X times quicker than where it used to be. I think it's relative. I can't put a number on it. That's why I put X. But I can tell you this, it's a 2-digit number. It's not just 4 or 5. I'll give you an example. The user check-in part, running that test on a Neo database with 500K nodes was taking about 4 to 5 seconds. That's just because we just didn't get our indexes right. Our queries were actually doing graph scans, which it shouldn't be doing because it should just look for the node it's supposed to be working with. And it came down to 39 milliseconds. That's the average time on 20 runs. So we run tests overnight and post data to hosted graphite. So it just draws these beautiful graphs, which tells us if the test is gone up or down every nightly build. In that sense, I think that's been a useful exercise. Being able to see it every day with feedback has been great in terms of actually being able to look at the performance of the system. The complexity of the work has reduced. Indicators, yeah. Teams not actually come up with anything like, I can't estimate this, it's too big, or our cycle times have increased. And I'm not telling you this just with finger in the air stats. I've got Q1 2015 to Q1 2016 worth of our cycle times for all the complexity of all the different people in the team who've been at Scribestar average out. And I can tell you the observation has been Q1 and Q2 2015, there were like some extra large stories which took 43 days each. Forget Agile, the 43 days each. And later on, in the later part of the year, we were averaging at 17, 18 on the cycle time. This, on the basis that the definition of cycle time changed. When we were doing that, it was just about developing and testing. This is now about developing, testing, going through a UAT phase, having a performance test review, and then going into our beta environment. So the cycle time, it has widened up, but the ability to actually build these things has been constant, really. So in many ways, this same problem we were solving in this other technology stack that we were doing 8, 9 months ago naturally tells me, for whatever reason, you can put as many reasons in this context. It's the wrong choice of technology, it's the wrong solution, it's the wrong set of people, it's the wrong set of driver for the product. It doesn't really matter to me. I am seeing results in terms of system performance as an architect, that system works really quickly. The next thing I'm actually able to do is actually show my COO the graph. He's an ex-general counsel. If he understands the graph, I bet you all of you can as well, because he's a lawyer. He looks at this graph, and he understands how the document's moved or the content is moved and who's worked on what at what point in time. That is very useful analytics out of the box from a model that you have. Linkurious, if any of you have heard about it, is one such thing I can just put on top of my graph model and give it to the support team or anyone who's selling this product to look at analytics, really. I don't have an ETL job. I don't have a reporting layer, but that's just my problem domain. I get it. You can't say this in every domain. I'm sure in financial services it's a different ballgame. But in this space, I think using Neo4j or a graph in general has been really good for us. And what I see for us moving into the future is if RavenFS is being naughty, I'm going to switch it around for some other file store which is more stored like an Amazon S3. We cannot put it on the cloud. We have to host it in-house. We have a system with bold security requirements. We encrypt all the data in these file stores, by the way. That's why it goes back and forth. So there's some latency added because of that security stuff as well. I think one of the things for the Neo4j guys would have been, I like Linkurious as a product. It would have been great to have it on the same dashboard as Neo4j, really. If I can actually translate the data as is in the same place and control access, I'm happy to pay the same money as I would pay for a Linkurious license. But it would have been a great idea to have it on the dashboard. In terms of value from the graph itself, precedence in legal is a very common occurrence. It's basically when you prep a document for a specific circumstance with a specific set of people, if that recurs in the future, it's a precedent, really. And that's kind of the way they start categorizing these documents and using it for historical reasons. So all that information, I think, is just going to come out of the graph naturally for us as more and more content flies into the system. That was really where I see, but that was one thing I definitely believe in. After this use case, I definitely say that's true. Works on my machine, by the way, so it just does it for me. Neo itself, I think, has been a good addition to our tech stack in terms of what it's given us. I think I have high hopes of how this is going to scale out for us, provided we sell the same cliche as everyone else. So thank you very much.